Hello, welcome everyone. In this video, I'm going to work out another example of the sum rule of derivatives. The sum rule of the derivatives states that the derivative of a function equals the sum of the derivatives of its individual terms. Okay, so we have a function which is the sum of multiple terms, and when we take the derivative of this function, we basically take the derivative of each of the individual terms and then add them up. So this is what we're going to use to solve this particular problem that we have. So I'm going to write it as we want to take the derivative d over dx of 3 over x squared plus 2x to the second power and everything raised to the third power. So this is the function that we have. To take the derivative of this function, we're going to separate each of the terms and actually take the derivative of each of the terms individually and then go ahead and add them up towards the end of the question. So I'm going to write it again, d over dx of 3 over x squared plus d over dx of 2x squared raised to the third power. So I'm going to go ahead and simplify a little further. So d over dx, and we have 3 here, and I'm going to separate this like a, so I'm going to write it as, instead of 3 over x squared, I'm going to write it as 3 to the x, 3 times x to the negative 2, because I can use the laws of the exponents property here, where if we have something in the denominator, we can bring it into numerator and change its exponent sign. So this is exactly what I'm going to do here. So instead of 3 over x squared, I'm going to write it as 3 times x to the negative 2. Okay, so we can switch the position of the exponent, the term that has exponent on it, and then change the sign of it. If it's in the numerator, we can bring it in denominator and change the sign of its exponent. If it's in denominator, we can bring it into the numerator and change the sign of its exponent. And then plus d over dx of this. I'm going to simplify it from here. I'm going to take the cube of this expression inside, or the term inside. So 2 cube times x squared cube. Okay. So next one, I'm gonna just simplify it further. Let me go to, so we have d over dx of 3x to the negative 2 plus d over dx, and 2 cube is 8, and x squared cube is x to the 6. We can just multiply the exponent and it would be x to the 3 times 2, which is 6. Okay, all I did is just multiply the exponents here. So I'm going to go to the next page. We have derivative d over dx of 3x to the negative 2 plus d over dx of 8x to the 6. Okay, and from here I'm gonna go ahead and apply the power rule and simplify this further. So before I do that, I can take out these constants out of the derivative term because they are multiplying, so we can pull them out of the derivative term and bring them to the front. So 3 times d over dx, we have just x to the negative 2, and we take 8 out, so this is 8 d over dx, and inside we have just x to the 6th power. Now we can go ahead and take the derivative. So 3 times, when we take the derivative, we bring the exponent of the variable to the front, negative 2 as a multiplier, times x to the negative 2, and we subtract 1 from it, plus 8 times the 6 comes to the front, x to the 6 minus 1. So we have 3 times negative 2 is negative 6, and x to the, when we add these two, negative 2 minus 1, or we subtract negative 1 from 2, we get negative 3 plus 8 times 6 is 48, and we have x to the 6 minus 1 is 5. All right, so you can leave it like this, or you can change this into the denominator and change the sign. So you can also write it as negative 6 over x to the third power. So all I did is brought this x to the negative 3 in the denominator and changed the sign of the exponent to positive, and plus 48 x to the fifth power. So both of these answers are correct. Okay, so you can either leave it like this, or you can go ahead and simplify it further and bring it into this form right here. All right, so this would be it for this example.